Hey guys, and happy Friday. Today is May 22nd, and this is for Math 1. This is on evaluating problems with compound interest. So this is more practice of what we did yesterday. The only difference is that we're going to actually be finding a certain amount for a specific number of years. And this is the last lesson for this year, so that's a good thing for you guys. Let's go ahead and get started, okay? So here's my question. It says, you want to invest $10,000 in an account that earns 5% interest. You have the option of having the interest compounded annually, quarterly, monthly, or semi-annually. How much money will be in your account after 20 years? Which option earns you the most money? So we're actually going to use all of the different ways of compounding our money and see which one is better for us after 20 years, okay? Now, first things first, you should have noticed that it said compounded. So you know from the very beginning, we got to use y equals a times b to the x, right? Whenever you hear the word compounded, okay? So that's the first thing. So I'm going to set it up here. I have all three, and we're going to compare them as we go, all right? Okay, so they tell us that we're going to invest $10,000, and that's the same for all of them. So all of them are going to have an A value of $10,000, right? That's the starting value. That's how much I have in the beginning. So they're all going to be the same because they're starting with the same amount. Now, they're all earning 5% interest, but they're earning it in different ways, right? Okay, so let's do annually first. So for annually, it's earning 5% interest total, right? So remember that we start with our original 100% always. This is the original, right? And then I'm earning 5%, right? So that gives me 105%. Then remember, I got to write that as a decimal. So 105% is 105 out of 100, remember, percent. And when I divide that, that gives me 1.05 as my B value. Okay? For semi-annually, remember, we have to take an extra step. Semi-annually means 2 times a year. So I have to start first, before I get to this, I have to start by taking that 5%, and I have to split it into 2 parts because it's happening twice a year. So that's really only 2.5%, okay? So then I'm gonna go back and do the same thing. I have my original 100%, and I'm still earning, but this time I'm earning 2.5%. So it's adding because it's earning. So when I add that, I get 102.5%. Okay? And then I got to write that as a decimal. So 102.5% is 102.5 over 100, which when I divide gives me 1.025. And that's my B value. So see, it does make a difference if I'm doing it once per year or twice per year, right? Let's go with quarterly next. So quarterly means it's happening 4 times a year. I'll put in parentheses here so you can remember. Semi-annually is 2 times a year. Annually is obviously only 1 time per year. Quarterly is 4 times per year. Okay, so 4 times per year. So I got to take that 5% and I got to split it up by the 4 times that it's happening per year. So that's going to give me, when I divide that, I'm going to get 1.25%. So I have the original 100%, and I'm earning still, but this time I'm earning 1.25%. Now that may seem really small, but trust me, over time, it makes a difference. Okay, so I got 101.25%. And I got to write that as a decimal, so 101.25% is 101.25 out of 100. And when I divide that, I get 1.0125, and that's my B value. Okay, and then let's look at monthly. So monthly, remember, is 12 times per year, right? because there's 12 months in a year. So I have to take that original 5% and I got to split it by 12 this time. So I'm going to do 5 divided by 12, and that doesn't give me an exact answer, but I'm going to do as best as I can. So you'll see, let me show you my calculator. So there it is, 5 divided by 12. So let's go with 0.4, and then I'll just round just to make it easier on us. This 6 would make the 1 round up to a 2. You can decide where you want to round it. Obviously, the more decimal points you have, the better your answer is going to be, but that's fine, okay? So 0.42%. Don't get confused here because you might think, oh, it's already a decimal. No, it's still a percent, right? I was splitting up that percent, just a very small percent. So I have the original 100%, and I'm still earning, but I'm only earning 0.42%. So when I add that, I get 100.42%. And remember, that means 100.42 out of 100, which is 1.0042, which again seems super small, seems like it's not even worth it, but trust me, over time it really is. There's my B value. So now I can write my equations for each of those, okay? So then my equation for this one would be y equals A, which is 10,000, times B, 1.05 to the x. This one, y equals A is still the same, times B. Now be careful, this is semi-annually, so 2 times per year, so I'm going to put 2x, where x is the number of years, or you could just think to double it when you put it in, either way, like we talked about the other day. Same here, y equals, starting value is the same, times 1.0125, and this is quarterly, so it's happening 4 times per year, so 4 times the number of years, and y equals, same starting value again, different b value, and this is happening 12 times per year, so I'm going to do 12 times the number of years. Okay, now let's go back to our problem. Now that we have our 4 situations, we have our 4 equations, they want to know after 20 years. Okay, so I'm going to put in 20 for x in each one and see what I get. Okay, so y equals 10,000 times 1.05 to the 20th. So let's put that in our calculator, and I'm just going to type it in just like that so you can see. So 10,000 times 1.05 to the 20th. So then that gives me, this is money, right? So $26,532, and then we want cents, so 90, and then that's 7. After the 7 here is another 7, so it's going to make the 7 round up to an 8. 98 cents. Okay, let's do the same thing for the next one. We'll substitute in the 20. So I put in 20 here, 2 times 20 is 40. And remember, we're doing that because if it's every half year, after 20 years, you're going to go through 40 cycles of that because it's 2 times per year. So I'm going to put that into my calculator again. Except this time it's going to be 40. Oh, and I did not put in the right amount. 2, 5. There we go. Okay, so that's the amount that it's going to give me there. So we get 26,000 again dollars, 850.6, and then the 3 after it, there's an 8, so that's going to make the 3 round up to a 4. Okay, so you can see this. Look at this here. They're both 26,000, but this one is a little bit better. You get 300 extra bucks. Hey, I'll go for that. Okay, let's try the next one. Same thing. We'll substitute in the 20. So y equals 10,000 times 1.0125. And then to the 4x, 4 times a year. So if it's 20 years, 4 times a year, that's going to be 80. So we'll put in 10,000 times 1.0125 to the 80th. And I get $27,000 this time. 0.8, and then the 9 after the 4 is going to make it run up to a 5. That's even better. It's getting better. One last one. Let's substitute in our 20 here. $10,000. And then it's 12 times a year, so it's 20 years. So 12 times 20 is 240. So I'm going to put in 10,000 times 1.0042 to the 240th. I get $27,343.30. After the 7 is a 3, so it's going to stay as a 7. Look at my prices here. Here, 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 here. Notice it's going up every time. Now, I know that's strange because you're thinking, hey, it's still the same 5%. I'm just splitting it up over the year. But compounding does make a difference. It does make a difference. So the best one is obviously the monthly. So we should choose to compound it monthly. Earns the most. Compounding monthly earns the most, as you can see right here. So these are all the kinds of things when you're investing or when you're doing anything with interest, you're definitely going to need to know about this in the future because they can do something on you that's you're not going to like in the future. If you have to pay that money back, you'd obviously rather have a loan like this. That's way less money I'm paying back. Or if I'm getting the money, then I'd rather have this one. So all these kinds of things. Let's just do a couple of separate examples just to make sure everybody's okay and no one's confused. Since that was all at once, that might have been too much for you. So we'll do a couple of separate ones just to make sure we're okay. So this one says you invest $2,000 for 5 years in an investment that earns 6% interest compounded quarterly. Okay, so we already know compounded means we're using our good old y equals ab to the x. That's the first thing we notice. Okay, so I'm going to use y equals a times b to the x. This is compounded. And we invest $2,000, so that's my a value. So a is 2,000. And we're earning 6% interest, and it's happening quarterly. Remember, quarterly is 4 times a year, right? So I'm going to do 6%, and I'm going to divide it by those 4 times that it's going to happen in a year. So I get 1.5%. And then I am going to say, remember, I'm starting with my original 100%, adding on the 1.5%, and I get 101.5%, which I can write as a decimal. So that's 101.5 out of 100, which is 1.015 as our B value. So then I can write my equation. Y equals 2,000 is my A value. B value is 1.015. And then it's happening 4 times a year. So there's my equation. Last step, they ask for after 5 years. That's the last step. They ask for after 5 years. I'm going to substitute in my 5 years. So y equals 2,000 times 1.015. And if it's 5 years and it's happening 4 times a year, that's going to give me 20 times. So then I'll put that into my calculator, just like that. So I'm going to go 2,000 times 1.015 to the 20th power. So then that gives me This is money, $2,693.71, because after the 1 is a 0, so it stays the same. That's how much money I'm going to have after 5 years, which is nice. Look, I made almost $700 just by keeping my money invested. Great deal. Let's look at another one, okay? Right, so then this one says you invest $4,400 for 2 years at a 7.3% compounded monthly. So again, compounded, so you know you're using y equals AB to the x. And this is your starting value because that's how much I'm investing. So my A value is 4,400. And then since it's compounded monthly, that means it's happening 12 times a year, right? Okay, so it's 7.3% compounded monthly. So I'm going to take that 7.3%, I'm going to divide it by the 12 months that are in a year. So on my calculator, I'm going to go 12.3%, I'm sorry, 7.3% divided by 12 gives me, it's not even, you can see, I'll just show you what I divided. So I'm just going to go, the 8 will round the 0 up to a 1, so I'll use 0.61. Remember, this is still a percent. Usually when it's happening monthly, you're going to get really small numbers. That's okay. So I have the original 100%, and then I'm adding on 0.61%, which, as we talked about earlier, doesn't seem like a lot, but trust me, it makes a big difference. So I get 100.61%, and then I want to write that as a fraction. So that's 100.61 out of 100, which is 1.0061. Seems like it's so small, it's not even worth it. Remember, the monthly one was the one that was the best in the last one, so it makes a difference. And we write our equation. Y equals starting value 4,400, B value 1.0061, and then it's happening 12 times a year, so that's going to be 12x. Okay, last step, they just want you to invest it only for 2 years. I'm going to substitute in my 2 years there. So y equals 4,400 times 1.0061, and it's 2 years times 12 months, which gives me 24. I'll put that in my calculator here. So 4,400 times 1.0061 to the 24th. So I get, this is money still, $5,091 and 40, after the 3 is a 5, so I'll call it 44 cents. Now I just want to notice this really quick, 2 things. Number 1, this was only saving for 2 years. Number 2, the interest rate is a little higher though, and it's monthly instead of quarterly as this one, and you started with more. Look at that. I made $1,000 more in only 2 years than $700 in 5 years. So it makes a big difference how much you're investing, what's the rate that you're investing at, and is it monthly, quarterly, annually, what's happening? Makes a big difference. Okay. All right, let's try another one here. Just doing a couple of practice ones just to make sure no one's confused, okay? So you borrow $30,200. That's a lot of money, but you're going to need to do that when you get older. Cars, houses, all kinds of stuff. For 5 years at an interest rate of 15.6%, and it's compounded semi-annually. So again, compound. So that's automatically in your brain. You should go, oh, exponential. Y equals A times B to the X. Okay? I'm borrowing $30,200. So that's my A value. That's what I'm starting with. And it at a rate of 15.6%, which is super high. That's awesome. Way higher than these. Notice this, right? Semi-annually. Now you got to be careful here because you're like, oh, that's great. Look at the percent is way bigger. I'm going to make way more money. But this is me borrowing. And this is really classic that they'll give you a higher interest rate when you're borrowing because you're paying them, versus when you invest it, they're going to give you a lower interest rate because they have to give you money. That's the facts of life, right? Okay, so 15.6%, and it's semi-annually. So remember, semi-annually means 2 times per year. So I'm going to divide that by 2. So 15.6 divided by 2 gives me 7.8%. Okay. Oops. And then I am going to find out how much my multiplier is. Don't forget about that step. So I start with my original 100%, right? And this is how much I'm gonna have to pay back. So I'm adding on 7.8%. That gives me 107.8%, which I then need to write as a decimal. So 107.8 out of 100 is the same as 107.8%. When I divide that, I get 1.078 is my B value. So now I can write my equation. So y equals starting value 30,200, B value 1.078, and this is happening biannually, so twice a year. And this is happening for 5 years. I'm going to plug in my 5 there. So 30,200. 5 years, twice a year would be 10. I'll put that on my calculator here. 30,200 times 1.078 to the 10th power. After 5 years, I owe $64,000. $64,000. So I've almost doubled what I owed here. See how important it is that you pay attention to when you're getting a loan? Like credit cards, for example, they make so much interest off of you. So let's say this was a car, a $30,000 car that I bought. If I'm owing just for 5 years, I'm trying to pay it off in 5 years, I have paid for 2 cars, more than 2 cars, because I bought it on credit versus saving up money and buying it in cash. Makes a huge difference. Pay close attention to that for your future. That's going to be so important. Okay, last one. One more example just to make sure we're okay here with all of these, okay? Last one. So your uncle charges you 13% compounded semi-annually to lend you $155 for 2 years. So again, compounded, so that we know y equals a times b to the x, and it's compounded semi-annually at 13%. So semi-annually we know means twice a year. And we're starting with $155 is what I'm borrowing from them. So that's the 155 is my starting value. And I have my 13% semi-annually, so I have to split it between the 2 times per year. That gives me 6.5%. So I have my original 100% that I'm borrowing, and I'm adding on the 6.5% I'm gonna have to pay back. What a jerk uncle that they're charging me interest. And I get 106.5%. So then we write that as a decimal. So 106.5% is the same as 106.5 over 100, which when I divide gives me 1.065. And that's my B value. So I can write my equation. Y equals $155 that I'm borrowing at a rate of 1.065, 1.0, yeah. And then it's twice a year, so 2x. And this is happening for 2 years that I'm borrowing money from my uncle. So I'm going to substitute that in the 2 years. 2 in here, 2 times 2 is 4. So last one, put this in our calculator here. 155 times 1.065 to the 4th power. And I get $199.40 since after the 0 is a 2. I'm paying my uncle about $45 extra for him lending me this money for 2 years. Makes a big difference. If you save ahead of time and use your own money, then you can make money off of people instead of the opposite way around. Okay, so be smart as you're thinking about your future. It's probably one of the most applicable lessons to think about what's happening in your future. Okay, lots of examples here. We did 8 total today, and we did some yesterday, and all that we did new today was substituting in. I did some of that the other day as well. If you have any questions, feel free to contact me, email, Google Classroom, Remind, whatever you need. I'm available. Have a great day and a great summer.